Swayam Prabha. Digital India. Educated India.
Hello friends. So, in the previous lecture we have discussed that linked net structure can be used for the determination of primary and backup relay pairs, and for that we have to use two algorithms. One is known as the algorithm 1. So, that is used for the calculation of 5 parameters, 2 that is this AND A and AND B, and 3 that is one dimensional vectors. And second, that is we have to use the algorithm 2, and in that we can calculate the 6-7 different parameters, so that finally we obtain the primary and backup relay pairs. So, for that now let us see one example, and we have also discussed the outline of the example, and we have discussed that this is the system of single line diagram where 4 buses are there and that contains 4 branches, and as I told you earlier, each branch contains 2 relays. So, total 8 relays are available in this given network, and using linked net structure we have to find out the backup relay pairs when I consider the case 1, in which I consider primary relay PRI that is equal to 2, and then I have to calculate backup relays. So, I call it this backup relay as RBU. So, we need to calculate this RBU for case 1, and for case 2 we have to consider the primary relay PRI that is equal to 6, and then we need to calculate the again the backup relays, and that we will again call it relay backup RBU. So, these two things we need to calculate for two different cases. In case 1 relay R2 we have to consider, and in case 2 relay R6 we have to consider as primary relay. So, now let us see how calculation can be carried out. So, when we consider the linked net structure, as I told you, two algorithms are available. One is the algorithm 1 and second is the algorithm 2. So, first we have to solve the algorithm 1, and for solving the algorithm 1 we have to prepare a table which is known as branch node table. Using algorithm 1, so if I write the algorithm 1 using this, I need to prepare the branch node table, and this table that can be used as an input for the algorithm 2 for the calculation of the relay backup or backup relays for a particular primary relay. So, this can be used as an input to algorithm 2. So, let us see using algorithm 1 how we can prepare the branch node table. So, for that what we have to do is we have to use 3 different things simultaneously. So, you can see this is our system which I have shown here. Now, here in this system I told you earlier also that you have to input the node data or bus data, whereas the relay data that is given by the linked net structure. So, here we have to prepare this table, and this table is known as the branch node table. and this table we have to prepare using this flow chart, that is algorithm 1. Now, let us see how we can achieve this. So, as I told you, in this case we have to prepare the table considering the first column as the branch. So, as I told you here, the 4 branches are there for this given network. So, in the first column I have to write branch and then branch 1, 2, 3 and 4, as 4 branches are available, and for each branch we need to calculate the 3 one dimensional vectors, that is next, least and far. So, this we need to calculate, right, that is next, least and far, these are the 3 one dimensional vectors, and before that we need to calculate the node, that is bus, and the end, these 2 parameters also we need to calculate. This end we need to calculate using this 2 equations that is used for calculation of end column, and node, that is bus, we can calculate using some logic. So, here first step is to prepare the linked net structure, and for that we have to prepare branch node table. So, if I wish to prepare the branch node table, then for a particular branch which is connected between 2 buses, we have to consider the lowest relay number. So, here if I consider the branch number 1, then this is my branch number 1, right, you can see this is my branch number 1, and for this branch 2 relays are available here, one is relay R1 and relay R2. So, the lowest relay in this branch, that is relay R1. So, opposite of that bus, so lowest relay number is relay R1, opposite of that, that is bus 1, I have to consider as node A, that is equal to 1, because node A is connected with bus 1. So, node A I will keep it as bus 1 and node B I will keep it as bus 2. Similarly, if you consider let us say branch number 2, so here in this case when you consider the branch 2, this branch 2, the lowest relay number is R3, and opposite of that bus, that is this bus again, bus 1, that is considered as node A, that is equal to 1, and the other bus, that is 2, is nothing but your node B. So, let us consider again the first branch. So, first branch we have 2 relays R1 and R2, lowest relay number is R1, opposite of that bus I am calling as node A, that is equal to 1, and node B, that is equal to 2. Once we have node A and node B, we can calculate the end using these 2 equations. So, end A is equal to nothing but you have the 2 into branch. So, branch I am considering, that is first branch. So, 2 into 1 minus 1. So, I have end A, that is equal to 1, and end B, that is equal to branch into 2. So, 2 into branch is 1. So, end B comes out to be 2. Now, once we have the node A, node B, end A, end B, the next is to calculate 3 one dimensional vectors, that is next, least and far. So, this we can calculate using these 2 blocks. So, let us see the first block, that is the next block. So, next and A, that is nothing but and A we have already calculated, that is and A is equal to 1. So, next and A, that is equal to list, I am calling capital L, and node A we have already calculated, that is 1. So, this is nothing but my list L1. So, N1 is equal to L1, you can see I have put it, and as no such value available. So, you initialize it that value as 0. Similarly, the next point, that is this point, the next point, that is list point, you can see here list node A. So, L and node A, that is known as available as 1, that is equal to and A. So, and A is again available as 1. So, you can see that my L1, that is equal to 1. And the last thing, far and A. So, F, that is nothing but and A is available as 1. So, F1, that is equal to node B, and node B I have already calculated as 2. So, F1 comes out to be 2. So, here you can see my F1 comes out to be 2. Similarly, if you take this second block next and B, so my next and B, so next is N and B. So, and B we have already calculated, that is and B is equal to 2, you can see here. So, and 2 that is equal to, again what you have, L and list node B. So, list node B we have already calculated, that is also 2. So, N2 is equal to L2 and that is equal to, if no values are available we can initialize it as 0. So, you can see I have marked it as N2 that is equal to L2 that is equal to 0. Then next we have to consider, that is this thing, list node B. So, we have list, that is L, node B you can have, that is the value, node B is equal to 2. So, L2 that is equal to nothing but and B, and B have already calculated, that is 2. So, its value comes out to be 2. So, L2 is equal to 2, and then you have the last equation for and B. So, that is nothing but F and B, that is nothing but 2. So, F2 that is equal to node A is equal to 1. So, its value comes out to be 1. So, F2 that is equal to 1. Similarly, when I consider the second branch, third branch and fourth branch. So, then let us say second branch. So, my branch that is equal to 2. So, obviously as I told you, for branch 2, 2 relays are there, R3 and R4, and lowest relay number is R3 and opposite to that relay bus, that is node A. So, that is node A is equal to 1, you can see here, and node B is equal to 2 because branch 2 is connected between 1 and 2. So, my node B that is equal to 2. And A and AND B you can calculate using this by putting branch is equal to 2. So, your AND A is equal to 3 and AND B that is equal to 2 into branch, that is 4. Now, you can calculate these two blocks, that is next, list and far one dimensional vectors. So, you can see, if I consider the first block next and A. So, next that is N and A I have already calculated, that is and A is equal to 3 for this branch. So, N3 that is equal to list node A. So, list and node A I have already calculated, that is 1 for this second branch. So, that is L1 and that is equal to 1, because you see that L1 is equal to, available value of L1 is as 1. So, whenever you calculate the L1 value you have to take the latest value. Similarly, when you take the next this one, that is list node A. So, L and then you can take node A that is equal to, node A is equal to 1 for this branch. So, L1 that is equal to and A you have calculated, that is 3. So, you now your L1 becomes 3. Earlier L1 has 1 value, now it becomes 3, and you have to use this latest value for further in the calculation of the branch 3 and branch 4. Similarly, you can have this last equation for and A, that is and A is equal to, you can see 3. So, F3 that is equal to node B is equal to 2. So, F3 is equal to 2. Similarly, you can have again this 3 values, that is next and B. So, N and B is equal to 4. So, N4 that is equal to list, that is L, and node B that is equal to 2, because you have already calculated for this branch. So, L2 and L2 value, L of 2 you have already available that value, because you have already calculated here. So, that value you have to consider here. So, L2 is equal to 2. Then you can have list node B. So, list node B that is equal to 2. So, L2 again updated, that is equal to and B is 4. So, now L2 becomes 4, and you have to use this L2 value for calculation of further branches 3 and 4. And similarly, for equation for and B. So, for and B is equal to F and B is equal to 4, and that is nothing but node A is 1. So, that value you have to consider here, that is F4 is equal to 1. you can see when I consider the branch number 3, then for third branch relay numbers are R5 and R6. So, lowest relay number is R5 and opposite to that relay bus, that is nothing but your node A. So, node A opposite to this, that is 1. So, for branch 3 your node A, that is 1, and node B, that is 3, because branch 3 is connected between bus 1 and bus 3. So, this is 3. Your AND A and AND B, that is nothing but branch number is 3. So, 2 into 3 minus 1 and 2 into 3. So, this value comes out to be 5 and 6. Similarly, when you calculate, use this 2 block, next, that is your N and A is 5. So, N 5, that is equal to list, that is L, and node A that is nothing but one value for branch 3. So, L1, and L1 value we have already calculated, that is equal to 3. So, that you have to consider here, and then L1 is updated by list node A is equal to AND A. So, list L node A is 1, that is equal to AND A you have calculated 5. So, value of L1 that is updated, and for AND A is 5. So, F5 is equal to node B you have already calculated, that is 3 here for this third branch. So, F5 is equal to 3, and same way when you consider this block, next AND B is equal to 6. So, and 6 is equal to list node B. So, list, that is L, node B, that is equal to 3, and as no such value exists, so we initialize it to 0, and now L3 value is updated. So, list node B, so list is L, node B, that is 3. So, L3 is equal to, again you have to see, that is equal to AND B is 6. So, L3 value that becomes 6, and similarly for AND B, that is nothing but for AND, that is F, AND B is equal to 6, and that is equal to node A, that is 1. So, this becomes 1. So, similarly when you consider the fourth branch, then you can see that for fourth branch you have 2 relays R7 and R8 are there, and lowest relay number is R7, opposite to that bus, that is bus 1 is your node A, and bus 2, that is nothing but bus number 4. So, node A is equal to 1 and node B is equal to 4, you can see here. Similarly, AND A and AND B, considering branch is equal to 4. So, this comes out to be 7 and 8, and these 2 blocks next AND A. So, next, that is N and A is equal to 7. So, N7 is equal to list node A, that is L, node A is equal to 1. So, latest value of L1 you have to consider, which you have calculated here, that you have to use it here, and then you have list node A. So, L node A, that is nothing but 1, that is equal to, that value is updated, AND A is 7. So, this value that comes out to be here, and then for AND A, so F and A, that is equal to 7. So, F7 is equal to node B that is equal to 4. So, this value that comes out to be here, F7 is equal to 4. Similarly, for second block next AND B, so N and B is equal to 8. So, N8 that is equal to list L, node B that is equal to 4, no such value exists. So, we have to initialize it as 0, and then L4 value is updated. So, list node B, so L node B is 4. So, L4 that is equal to, we have to assign it as AND B is 8. So, that value now becomes 8, and for AND B, so for AND B is 8. So, F8 that is equal to node A, that is 1. So, that value becomes 1. So, this is how we can prepare branch node table in linked net structure using algorithm 1. So, once we have this value, we can utilize this value in algorithm 2 for the determination of primary backup relay pairs. So, let us see how we can use this branch node table in determination of primary backup relay pairs. So, this is our branch node table which we have obtained from algorithm 1. This we have obtained from algorithm 1. Now, as I told you, the backup relays of primary relay are 2. So, I told you that in this network, for this relay as a primary relay, I want to find out which relays will provide backup. So, for that, let us see my primary relay PRI, that is equal to 2. So, here in this flow chart for algorithm 2, my relay number becomes 2. So, as my relay number is 2 and this is relay is even relay. So, my IT is relay minus 1, relay number is 2. So, IT becomes 1. So, value of IT is 1. Once you have this, let us calculate these 3 values. First IFLT. So, IFLT, that is equal to far of relay. So, far is nothing but F, and relay number we are considering as relay number 2 as a primary relay. So, F2, and F2 value we have to consider it from this branch node table, and that value you can see here, that is 1. So, this value comes out to be 1. Then the next is you have IB. So, IB value is nothing but the IB is equal to list IFLT. So, list is L and IFLT value is 1. So, that value you have to put it here. So, latest value of L1 you have to use from this branch node table, and you can see that latest value of L1, that is 7. So, this value becomes 7. So, IFLT is 1, IB is 7, and now third thing we need to calculate, that is IS. So, IS is far of IT, and IT is already known, that is 1 value. So, we have to consider here. So, far 1 and far 1, this value is 2. So, you have to use this and keep it as 2. So, once you have these 3 values, you can have another 2 values of IF and IN. So, IF is nothing but far of IB. So, F of IB, IB is nothing but you have already calculated, that is 7. So, that 7 value is available here, and F of 7 is nothing but 4 value. So, this value becomes 4, and once you have IF, then you can calculate the value of IN, which is nothing but next of IB. So, IN is equal to next, that is N of IB, IB is 7. So, that 7 comes here, and N7 you can use it from this table. So, this value is nothing but 5. So, you can put it as 5. So, now you have the values of IFLT, IB, IS, IF and IN, all 5 things along with IT, and your primary relay number is 2, and using this logic you can have the backup relay. So, let us see, IF is equal to IS and IN is equal to 0 and IB is equal to IT. This is not true, because your IF, that is 4, IS value, that is also you can see from here, that is 2. So, this is not true. So, obviously, it comes here. Again IF is equal to IS, this is also not true. So, obviously, you will be here, and your backup relay RBU, that is relay backup, is IB. So, you can see that your relay backup is IB, IB value is 7. So, for primary relay 2, relay number 7 will provide backup. So, relay R7 is one of the backup relay which will provide backup if relay R2 fails to provide protection. Again you have to move, IN is 0, but no, IN value is not 0, its value is 5. So, again you have to assign this IN value to IB. So, earlier IB was 7, now it becomes 5. So, again with 5 you have to update these 2 parameters only, IF and IN. So, if you update the IF and IN, because your IF you can see here, your IF, that is nothing but far of IB. So, far of IB, IB becomes 5 now. So, F5, and you know that F5, that is 3. So, you can put it as 3, and IN here you can see, that is next of IB, that is next of 5, IB is 5. So, you see that N5 is also available, that is 3. So, here you can see that N5 that is available as 3, and you can put it here. Now, again you can compare whether IF is equal to IS. So, IF is 3, IS is already fixed that is true. So, no, it is not equal to IS. So, again you are here you are here, and again you have to see IF is equal to IS. IS value is 2 and IF is 3. So, again it is not equal. So, your RBU is equal to IB, and so you can see that your IB is 5 because we have taken IB as 5. So, your RBU is nothing but that becomes 5. So, for relay R2, relay R5 will also provide as a backup relay along with relay R7, and see if you continue further, because still IN is not 0 because IN is 3. So, again you assign this value of IN to IB. So, now your IB becomes 3 from 5, and again you calculate IF and IN, and you can see that you will have another backup relay, that is R3. So, for primary relay R2, if you see, then relay R7, relay R5 and relay R3, these 3 relays will provide backup to primary relay R2. So, if you see the diagram for relay R2 as a primary relay, relay R3, relay R5 and relay R7, these 3 relay will provide backup if relay R2, which acts as a primary relay, fails due to some reason. Similarly, you can see that our second case which we have considered, if I consider primary relay as relay R6 instead of here R2, I am considering PRI as 6, and if you consider PRI as 6, then you can see that again you can calculate, this is a even number. So, again your IT is 5, and again you can calculate these 3 parameters IFLT, IB and IS, because your IFLT is nothing but far off relay. So, far off 6, that is 1. So, its value becomes 1. Again your IB value is list of IFLT. So, IFLT is 1. So, L1 is nothing but 7 latest value. So, this is 7, and your IS, that is nothing but F far off IT, and IT is nothing but 5. So, F5 is nothing but 3 value. So, that comes here. Then you can calculate IF and IN, that comes out to be 4 and 5, and again you can compare, then you can obtain that if I consider relay 6 as the primary relay, then the relay R7 will provide backup, right, relay R7 will provide backup, and if you further repeat, then relay R3 will also provide backup. So, for relay R6, 2 relays, relay R3 and relay R7 both will provide backup if primary relay R6 fails to operate. So, you can also write down the code for this linked list structure for both the algorithms. So, if you enter, let us say in step 1 the data for any 9 bus system, where the system of 9 bus I have shown here, right, and you can see that the number of branches, that is from A, B, C, D, E, F, G, H, I, J, K, L. So, these are the branches, I think total 12 branches are there, 24 relays are there. So, for this relays you can prepare the branch table using algorithm 1, and that table looks like this. If you write the code and if you execute the program, then you will have the table like this, which contains node number, end number, next, list and far, 3 one-dimensional vectors. Once you have this, and if you have such type of code, let us say in MATLAB, then you can obtain the primary backup relay pairs, and you can see that you will have the output of primary backup relay pairs, that is output of algorithm 2, like this, where you have first column shows the primary relays. So, all 24 relays are there, and for each relay I have written which relays will provide backup. So, maybe for some relay only one relay will provide backup, for some relay 2 relays will provide backup, and you may also find that some of the relays like R17, 3 relays may also provide backup. So, this is how you can have or you can calculate the value of primary backup relay pairs. So, in this class we considered one example, and we have seen that if we use the linked net structure, then using algorithm 1 we can prepare the branch node table, and using algorithm 2 we can calculate the primary backup relay pairs. Thank you very much.